The topic of this video is, why were the names even and odd chosen? Where did the names even and odd come from? Why were they chosen? Well, to be able to answer that question, I need to give you a definition. A polynomial is an expression of the form box plus box x plus box x squared plus box x cubed plus box x to the fourth plus etc., where each box contains a real number. All polynomials are functions. It turns out that polynomials consisting of only even exponents, like the 0 and the 2 and the 4, have y-axis symmetry, and polynomials consisting of only odd exponents, like the 1, the 3, the 5, have origin symmetry. A polynomial that includes a mixture of even and odd exponents has no symmetry. Let's look at a couple of examples here. Okay, here's a polynomial. 4x to the fourth minus 3x squared plus 9. Okay, so this meets the definition of a polynomial because 4, -3, and 9 are all real numbers, and the exponents match the kind of exponents from the definition. The other thing that should be mentioned is that this doesn't technically have an x written, but 9 is the same thing as 9x to the 0, and 0 is an even number. You might recall from your previous math lessons that anything to the 0 power is 1. So this is really just 9 times 1, which is 9, and that's the reason why we can rewrite 9 as 9x to the 0 power. So with this in mind, all of our exponents are even, 0, 2, and 4, and therefore this is an even function. Okay, next, let's say I have this, -x to the fifth minus x. All right, what are the exponents this time? 5 and 1, because even though we didn't write the 1, it's an understood hidden 1 here. Both of these are odd, and this is a polynomial, which makes this an odd function. Okay, let's try another one. 3x cubed minus 2x squared. Well, this is a polynomial, but it includes a mixture of odd and even exponents within it. And for that reason, it's not even, it's not odd, this is neither. Neither even nor odd. And as a final example, I'd like to throw this one into the mix. So, you might be thinking to yourself, okay, so this is an x, which is x to the first power, and that is an odd number, so therefore this would be an odd function. But this is not an odd function. And the reason why is because the square root of x is not a polynomial. Polynomials are not allowed to have special symbols in them like square root or absolute value. So for this reason, we cannot use the shortcut. So how would we determine if this is even, odd, or neither? We would go through the long-form algebraic approach that was presented in another video.